Hello, folks. Welcome to Augmented Intelligence. I had to change the name of my channel because artificially was probably not very searchable on YouTube, and I got some feedback from some of my friends, so I decided to change the name of my channel. Please join my Patreon if you haven't joined yet, because I will upload all the good tutorials that I'm making solely for Patreon, and every time I compete in Kaggle, I will upload the notebooks and the tutorials on how I wrote the notebooks on Patreon. So today, I'll show you an overview of my latest Kaggle competition that I competed with one of my friends. And we did not do as well as we thought we would because there were some challenges in the submission, and I will go over them with you. But before we jump into that, please subscribe to my YouTube and subscribe to the AI podcast where I interview other people from the industry and how they use AI or how they're approaching AI research. And it's on Spotify, Apple, and Google. So please subscribe to those as well. So let's jump in. This is the submission list that I have for Kaggle in this competition, which is about American Sign Language fingerspelling recognition using AI. So the goal of the competition is to detect and translate American Sign Language fingerspelling into text. And because it is fingerspelling, which means that there are some words assigned to some of the words in American Sign Language, for example, elephant, and how, you, me, words like that. But in fingerspelling are usually used when you are spelling out a name, an address, because there isn't a particular sign assigned to that word particularly. So that's when you use fingerspelling. And there are a set of rules during submitting the notebook for this competition. For example, we will go over them here. So to submit the code, and this competition only takes a submission.zip file, which is a zip file of the model that you make, which had to be a TF Lite model. And I will go into the details of what is TF Lite, how does it work, and all that good stuff. And for now, just have to follow these rules. For example, whether you are using GPU or not, your notebook should not run more than 9 hours. The final file must be a submission.zip file, which is the zip of your model, which has to be a TF Lite file, TensorFlow Lite file. We will go over the data in a second, but first let's look at the submissions. So I've been trying to get into Kaggle submission for 4 days now, and yesterday was the last day of submission, and all of them were failing because I ran into a problem of timeout. So submission notebook exceeded the allowed runtime, and it is because they have a rule in this competition that the inference time shouldn't be more than 5 hours. And our notebook kept running over 5 hours, which is why we ran into the problem of this timeout for notebook. They probably have a huge data set, although it's not a good excuse, because the rule applies for everybody in the competition. And if you look at the leaderboard, our submission actually was scored at 0.409, the private score, which is based on the secret notebook that Kaggle has for this competition. And in the leaderboard, the top submission has 0.836, which is really high. And we are all the way down here at 1074th rank, which is not very good. And I hoped to do better. But just to get the submission in, I had to reduce the size of the network, the neural network heavily. And because in this challenge, because it's a sequence detection, everybody used a transformer. I'm pretty sure almost all of them use transformer, although I'll go over the top 5 submissions at least for this competition, and I'll put them on Patreon first, and I will probably make some of them available publicly, but I'll keep most of them for Patreon. If you look at the public score, the top rankers are still there as usual, and we are all the way here again at 1074 at a public score of 0.457, which is pretty close to almost all of them. Seems like a very average score for this competition. But the late submission link is still on. I'm not sure how long they're going to keep it on. So if you want to submit your notebook before or after watching this video, please go ahead, do that. And I'm submitting one late submission now as well, which is running at this point. Not sure whether it's going to be accepted or not, but the leaderboard is probably frozen already. But it doesn't matter. I just want to see whether I can do better in the public and private score. Having said that, let's look at the data. So you have this train.csv file here, and how it's sort of set is that you have training landmarks, and I'll get into the details of what landmarks are. The landmarks come from MediaPipe, so we have to discuss a little bit about MediaPipe. And inside the landmarks, that you have per-k file, which is a Apache file format for big data, because these files are massive. Each per-k file is close to 1 or 2 gigs, and you have hundreds of them. So the whole data set is close to 150 gigs. So make sure that if you're downloading the dataset, you have enough space on your device to store that much data. And so the per-k file name matches the file ID. And inside one file, you have a bunch of sequences. So for example, in this per-k file numbered 5414471, you have this huge chunk of sequences, and each sequence is made up of some frames, and each frame corresponds to one single frame of hand movement. And because remember, we are doing finger spelling, so the landmarks are on both of your hands, and you can do a lot more stuff, because the landmarks consist of landmarks on face, body, pose, everything. And ideally, I used the hand landmarks. That is probably ideal, but I'm pretty sure others have used some other landmarks as well to make better predictions, because even though in ASL, when people speak in ASL, they don't usually use their lips movement, but because some people can speak even though they use ASL, they can use their facial expressions, and they can spell it out while speaking the word. So yeah, probably using lip movement is also a good idea. But each sequence corresponds to one single phrase. So remember, you have file. Inside file, you have a bunch of sequences, and each sequence has a bunch of frames, and all those frames inside that sequence correspond to one single phrase. For example, the first sequence, which has, let's say, 100 frames, that corresponds to 3 Creek House, which is probably an address, and that almost all phrases are either addresses, URLs, phone numbers, or some sort of numbers, as you can see here, which is why you have to use finger spelling as opposed to using words in ASL to sign something. And that is how the data set is set up. And the goal of the challenge is to pre-process the data, and then you have to follow this JSON file, which is also given from the Kaggle challenge, which is a dictionary of different types of characters used in the phrases and their corresponding integers, which gives you a hint that you're going to use some sort of tokenizer to convert that character into some sort of integer or any other tokenizer, just like any other natural language processing challenge standard stuff that you do. But I'll go over everything in detail for sure in the upcoming video. For now, I just wanted to give you guys an overview of what's coming from this series of video for American Sign Language finger spelling recognition series that I'm making. Probably mostly for Patreon. They'll have people who join Patreon will have access to much more content, but yeah, I'll make at least our submission public on YouTube. So thank you so much for watching this video, and I'm hoping to see you on the whole video series.